Let's do a practice problem with some satellite motion. In this problem, we have a rocket blasting off of the Earth, going into a circular orbit. And we want this orbit to have a period of 3 hours. What I want to know is, first, what is the height that this rocket will orbit at, and what is the velocity that we need to achieve in order to get to that orbit? We're going to use these two equations that we derived previously. So, a period of 3 hours, the first thing we need to do is we need to convert this into seconds. How many seconds are in 3 hours? Well, to do this, I'm just going to go 3 hours. And in 1 hour, there are 60 minutes. And in 1 minute, there are 60 seconds. That's going to give me 16 million, so I'm going to go 16.5 million, and that's going to be E6 seconds. So that's going to be our orbital period. And I'm going to come down here, I'm going to start plugging that into this equation. I have 2 pi, I have radius, I have the gravitational constant, and the mass of the Earth. Now, this radius is going to be my total orbital radius from the center of the Earth. So when I want to find the height, I'm going to need to take my pink radius, that one, minus the radius of my Earth. So let's get started. So if we plug our numbers in, we're going to get 16.5 E6 equals 2 pi times the square root of r cubed over 6.67 e negative 11 times, let's extend this a little bit, times my mass, which is 5.972 E24. So let's simplify these numbers. Let's get these broken down. Let's divide both sides by 2 pi right off the bat. And then let's get rid of the square root by squaring everything. And then we'll put these two numbers together so we have something a little cleaner to work with. When we do that, we get 6.9 E12 equals r cubed over 3.98 E14. And so let's multiply both sides by 3.98 E14. That'll give us 2.7462 E27 equals r cubed. So now we just need to take the cube root of this, which, if you don't have a cube root function on your calculator, can also be done by taking 2.7462 E27 to the power of 1 over 3. That'll give us r. And so our radius is 1.4 E9. But remember, this is radius from the center of mass. And so we still need to subtract the radius of our Earth. So we're going to take that value. We're going to take our, let's do that over here. We're going to take our radius that we found, that 1.4 E9, minus the radius of the Earth, which is 6.378 E6. That'll give us our height, which just brings us down to 1.39 E9 for our height. And now that we have our height, now that we have our radius, 1.4 E9, we can plug that in to our velocity equation. We can determine our velocity. That velocity is going to be 533 meters per second.